Hi, everybody. My name's Aaron Falk. This is the Hotrfc Lightning Talk session. The purpose of this session is to create an opportunity for folks who are looking for collaborators in the IETF to have a chance to speak briefly, talk about their problem or their idea, and give enough information so others who might be interested will know enough to follow up. And so each talk should include some information on how to collaborate afterwards. There are, in the agenda for this meeting, there are short abstracts for each of the presentations, and they all include email addresses, and some include some additional information for how to follow up. So really the goal here is to try to connect people together. The way, so this is the first time that we've done this as a live online meeting. I'm sure that most of you have done a lot of live online meetings recently, so I think that the mechanics should be pretty familiar. But because these are intended to be lightning talks, I'm going to be pretty strict about the time allocation. So you've got 4 minutes. When your 4 minutes are up, I'm going to interrupt you and ask you to wrap up if you haven't already. I will be making just the sort of the WebEx interface. I will set you as the presenter when it's time for you to present, you can show the slides from your own machine. We've got one case where I'm going to be showing the slides. And I think that is everything that I wanted to say to introduce. So our first speaker is Mike McBride. I'm going to set him to be the presenter. And Mike, if you would unmute yourself and start, and I will start the timer.
Can you see my screen okay?
Yes, now you're doing the present. Oh, yep, looks good.
Okay, great. Thank you for letting me do this. So yeah, so we have this data discovery topic that we've been batting around, several of us, and we wanted to present this to this crew just to get feedback. Hopefully others can participate. Maybe someone will tell us we're crazy, or someone will say this has already been solved, or hey, maybe this is a good idea and we need to figure this out. So this is data discovery. We do have a couple drafts that we're kind of describing the problem. So this did evolve out of a series of edge computing side meetings. This is not edge computing specific, but we, in these edge computing side meetings, identified a variety of gaps. And one of those gaps was data discovery, discovering data that's distributed across the edge and how to find that data across different edge databases and needing to evaluate that. So that's how this has created. So what's the problem? The problem is that we want to locate distributed data in a standardized way. There are many proprietary ways of doing that. AWS, Macy, and IBM has a solution. There's many of the ways that you can do that. But we need to find a standardized way of doing so. Data may be cached, copied, or stored across multiple locations in the network en route to its final destination. And so we're trying to find a way to do, and we haven't come up with any solutions, just the problem. Kind of come up with a standards-based solution to discover where the databases exist throughout a network first, and then where specific data objects are located that we're looking for. So the location of each data store is the first level discovery problem, and then the details of the database directory is the second level discovery problem. So so what's data? Data can be anything. The kind of the use case that we're looking for is finding statistics, measurements, temperature. One of them is using an elevator, for instance, when you have sensors all over the elevator and you're trying to gather that data, whether it's vibration or braking information or speed or capacity or whatever, and then find out where that data is located. And data can be a program, it can be a service, and it can be a resource, CPU or memory, things like that. So that we're trying to find ways to find that data. So, what's next? So we're trying to determine if existing protocols will work here to do that. You may be able to find ways to extend existing protocols, DNS, for instance, that may not be a good idea, but it's one way that we've been thinking about of maybe trying to find where certain data is. If not, target where a new standard protocol may be needed. We've presented this in COIN, Computing in the Network Research Group in the IETF, but and we'll be having a discussion this next week in COIN. But maybe if this is valid work, then maybe we someday will try to create a working group first going through the BOF. So that's really it. Please look at the drafts. This is how you can contact the authors. You can email me directly if you wish to help provide some feedback or get involved in the work. And that's it. Thank you.
Thanks a lot, Mike. That was great. I'm now making Yaron Sheffer the presenter, who's going to give the next talk. Yaron,
Thank you, Aaron.
Start whenever you like.
So, hello everyone, I'm Yaron Sheffer. I'll be talking about ciphertext format. This actually is related in a way to the same problem domain as Mike's, in that he's looking to discover data overall. I'm looking to be able to find out encrypted data and attribute encrypted data back to whoever generated it. So there are lots of standards for the ciphertext, the raw ciphertext. What do you do when you encrypt something? What do you get when you encrypt something with AES, for example? Where does the nonce go into? Where does the authentication tag and so on? But if you have a huge amount of encrypted data around the enterprise in many, many locations, many databases, many files, it's just not enough to have a standard for the ciphertext. You need something else, something extra, usually a set of headers prefixed to your raw ciphertext to determine where it's coming from. And there is, surprisingly enough, there is no standard for this kind of metadata around encrypted data. There are some standards for data in motion, some standards in the PKCS 11 and KMIP world, but no standards for data at rest that apply to more than one key management system or more than one library. So the goal is to have, to some degree at least, self-identifying encrypted data and to enable interoperability of encryption libraries and key management systems that are related to them. The standard format should include at least key identity and a way to version keys so as to allow for key rotation. Of course, it needs to be extensible, just like any other broadly used format. It's very important for the data header to allow for detection of encrypted data. So there must be a way for someone who doesn't have the keys to look at this column in the database and say, hey, this is all encrypted data. And it follows this standard. And in fact, one fixed byte is good enough if you want to detect encrypted data at scale. And it needs to support granular key management, where people use key wrapping or key derivation to have a very large number of keys, possibly a different key for each encrypted field. There is an early draft of the proposal. I'm looking for partners to work on this with. And if you're interested, please reach out to me. Email is simplest. we can set up an informal meeting next week and then decide where to take it to. It could be a BOF, it could be SAG, CFRG, or somewhere I haven't even thought of. So again, if you're interested, my email is here, and if you have the slides, there's a link to the very early proposal. Thank you.
Thank you very much, Yaron. Okay, our next speaker is Shigeya Suzuki. I'm making you the presenter. And Shigeya, you can start whenever you like.
Hi. I'd like to provide an update on the blockchain governance initiative network, which I mentioned several times in the past few IETFs.
Shigeya, I apologize for interrupting. Can you go into full screen mode? It's your slides are
okay, sorry. Is working?
Better. Thank you. Yes.
Okay, sorry. Let me provide an update on the begin, which is a multi-stakeholder community for addressing issues in the blockchain ecosystem with among several stakeholders, not only the engineers, but also the regulators, consumers, and the commercial. We think that we need to solve some certain kind of problem related to the, for example, the development how we can secure the blockchain system or provide some way to tackle with anti-money laundering scheme, for example. So we have launched the group in March, finally. And currently we have 2 active working groups, which one is a governance working group, which is to try to design the community itself. And I'm one of the co-chair of the governance working group. And the other one is IAM, privacy and key management study group, which is working on key management or other issues related to the blockchain key management. So we're currently focusing, governance working group is currently focusing on the mechanisms of organization of the begin itself, and we are drafting 2 documents. One is a process document, and the other is an IPR process document. So this is usual stuff for the such type of a community, but we need to the version which is adjusted for us. And we are preparing this for the next general meeting, and we will be ready for the draft is ready soon. The other thing is that privacy and key management study group, which has 2 work streams. One of them is a key management work stream, and the other is the decentralized financial technologies and privacy, identity and traceability work stream. That is very long name. And both of them are currently developing document, and there is drafts already on the Google Docs, so you can review it if you like, and then it is possible to join and speak up if you have interest or like to comment. We are currently planning our first real general meeting in called block number 1 meeting in the late November. That is November 23rd and 25th. And the time is adjusted to virtual Mumbai. So it will be the noon to 3 p.m. UTC. So please come to join if possible. So the agenda will be tutorial and working group and study groups discussions, of course. And the information on the registration is available from this link, which you can find from the PDF I'm going to upload. So to join the begin, in general, as a member, please visit the website above or just contact me to find out if you want to discuss this thing and you want to know a little more about this, then please let me know. I'm happy to communicate with you. Thank you very much.
Thank you, Shigeya. Our next speaker is Pascal Urian, and I am going to share the slides from my machine. Pascal, you can, let's see, go to screen. Pascal, you can start anytime.
So this talk is about URAP everywhere, anytime, which relies on two IETF drafts, TLS-SC and TLS-IM. An open implementation of this draft is available at GitHub. Next slide, please. What is the concept? You want to put your application online, but for privacy reasons, you want to keep control. For that, application is embedded in a secure elements. Secure elements have several form factors like SIM, but they can be also integrated in SOC. Secure element evaluation assurance level is about 5 to 6, given a maximum value of 7. Your app server works over a TLS 1.3 embedded server. TLS-SC stands for TLS secure element and is described by an IETF draft. Your app client works over a TLS 1.3 client, which means that client credentials are stored and used in a secure element. TLS-IM, which stands for TLS Identity Module, is described by an IETF draft. You see on your right, your app working over a TLS 1.3 embedded server over an external TCP/IP interface. Next slide, please. So why TLS 1.3? Because it is a state-of-the-art for communication security. It is a result of several years of debates between security experts at the IETF. Privacy is announced by different exchange over elliptic curve. Channel security relies on authenticated encryption with associated data. Server and client authentication are based either on public key infrastructures, PKI, or pusher key, PSK. So TLS-SC 1.0 works with ILS CCM cipher suits, elliptic curve Diffie-Hellman, and 32 bytes pusher key. Next version will support PKI. Next slide, please. This slide shows an application. Oh, sorry. Is it the next slide? So can you go before? Okay, so I am lost. Okay. So this slide shows an TLS 1.3 basic exchange using TLS-IM and TLS-AC. TLS-IM is optional. You can choose a pusher key based on passwords, the hash of a password, for example. And your app is running over the TLS-SC application and embedded in a secure element. And the PSR acts as a kind of super pin code. So next slide, please. So this slide shows you an application example, a blockchain key store. The right part shows ASCII command used to generate key, to set key, to compute key, according to the BIP32 specification and to sign transaction. The left part is a low-cost prototype board. An Arduino Mini is used as reader for secure elements. It manages the ISO 7816 protocol and provides you interface with the Wi-Fi SOC. The Wi-Fi SOC has a TCP/IP stack and perform network exchange. So next slide, please. Scalability is an important issue, still open. Is it possible to deploy your app in the internet? That's the question. On the left, a trivial use case, a simple socket IP endpoint is used. As illustrated in the middle part, multiple ports may be used with single IP address. And finally, on the right, a single socket IP endpoint is used by several server names. Server name is an extension included in the TLS hello message. So secure elements can be identified by example by 15 byte located in the answer to reset message as described in the TLS-EC draft. So next slide, please. And thank you for your attention.
Okay, thank you, Pascal. need to stop sharing here. Next speaker is Li Yizhao. And she's going to be talking about Dinecast. Yizhao, I'm making you the presenter, and you can start whenever you're ready.
Okay. Hello, this is Yizhou speaking. I'm going to give a briefing on the Dinecast or the dynamic anycast. A quick capture of the idea is trying to routing the service request based on both the computing and the network metrics. Okay. This page tries to illustrate the problems in edge computing. With the increased deployment of edge computing from the operators, we find that there could be a very large number of edge sites. For example, there could be a couple of edges for each district within a big city. And another feature of the edge is they have very limited computing resources, and the computing resources are varying all the time for each of the sites. So naturally it comes to a question, which edge is the best to route a computing demand to? So here we try to focus on the computing service. So there are three aspects we want to consider. The first one, which one is the best? We need to consider the computing resources and the load attached to a particular edge site. Probably want to choose the most lightweighted one. And the second to consider is what's the network path quality to a particular edge and what's the network status. And the third aspect is, since the computing resources and the network status all vary over time, so we want to know all this information in real time. So that's the problem we are trying to tackle on. So to illustrate the concept of Dinecast here, here I'm using a like a 5G deployment here as for illustration purpose, but it's not necessarily to be the 5G backhaul deployment. So basically, we have two MEC sites, and there is a client comes in, and then with the most current practice, normally this edge computing request will be handled by the local MEC site, which is site 1 here. But it could possible that, for example, because in working hours, the industrial park usually have much higher load, and the residential area normally not. So in some of the cases, the CFN node here, which is a mini data center gateway here, can determine that this computing request would be best handled by the MEC site 2. So that's the green line shows where the data flow goes. So the client normally use the Anycast address to access a service, and this packet would be routed to the best edge in terms of both the computing resources and the load and also the network status. And which one to be chosen is transparent to the client. All client knows is the Anycast address to access the service. That's why we call it the dynamic Anycast. So there we presumably there should be some protocol change, both the data plane and the control plane. So the brown arrow lines there indicate there should be some control plane information change from the server to the data center gateways, and also between the data center gateways or the CFN nodes, which are the blue lines here. So we want to actually, we want to propose 3 features to be supported in Dinecast. The first one is the Anycast-based service addressing methodology. Then the second one is to ensure the flow affinity. Then the third one is the computing-aware routing. this slide show the activities we are going to have for the coming IETF week. We are having a side meeting on Wednesday. It starts 5 minutes after the IETF plenary ends. So it will be a 75-minute session. So the WebEx can be found here, and also the WebEx can be found on the side meeting wiki, which is URL here. So the purpose of it, we're trying to understand the use case problem space and review the framework, and also discuss the potential work and where to fit them in IETF. So you're welcome to join us. Thank you.
Thank you very much. Our next speaker, I think, may not have joined yet. Do we have Zadago Sako on the call? I'm not seeing anybody by that name in the participants. Okay, I think not. I'm going to move on to the next talk. So Massimo Nilo is going to talk about Android explicit monitoring app as soon as I can make him the presenter. Okay, Massimo, you can start whenever you're ready.
Okay, my name is Massimo Nilo. I will present our work about an Android explicit monitoring application. What are the goals? Our goal was a mobile tool for traffic performance monitoring of encrypted transport protocols, also using the explicit flow method for measurement. The explicit flow measurement employs few marking bits inside the header of each packet for loss and delay measurement. It's protocol independent. It is valuable particularly for encrypted headers. Real quick. The idea was to giving the monitoring power to customers. Our application is an Android application based on Ericsson spin dump open source code. Then, okay, the name of application is Team Quick. With presentation and a live demo and the hackathon that is just finished. The first idea was already introduced in the last Hotrfc in July, and was how to measure network performances with user devices. There is a YouTube video that you can see. There are also two related drafts that describe the details, the ideas behind and the details. One is about explicit flow measurements, and the second one that is just a new draft is user device explicit monitoring. Here are the links. Here is the link to the project, the library on GitHub. Here there is some screenshots of the application. The idea is to placing the explicit performance server on the user devices that give many advantages. For example, in terms of scalability, in the measurement precision, and in saving in hardware deployments, for example, hardware deployment for the probes. A good idea was to have a real-time mobile traffic monitoring. In this example, you can see for example, the list of connections and the details of the measurements. Exactly, for example, when you launch the YouTube application with the video that flows continuously, you can see directly in real time what happens to your connections on the network and what are the measurement about the time or loss and what kind of connection are you using. The operators with the customer permission may use this information to identify network problems and improve the customer experience. What are the main features of the application, of this mobile application? The first is the customer choose whether to mark his mobile traffic or not to mark, making it monitorable by the Android application and the network probes. The second feature is also that the customer choose whether to share the performance data, for example, that the app on his mobile phone has collected. The third feature is that should be possible in the future to put performance thresholds on the probe in order to signal connections with problems to the network operator. Thus, the network probes will primarily monitor only the connections that are affected by impairment on loss or delay and help to localize the problem. If you want to, next Monday, we have the IETF working group meeting, and we will present our two drafts. And also, we participate in the hackathon with this development. Here you can find our contact details.
Thank you, Massimo. So that was our last talk. I'd like to thank everybody for attending. Presenters, if you haven't already done so, please either upload your slides yourself or send them to me and I will do so. If folks heard anything that was interesting, feel free to follow up directly with the presenters, and also send me feedback on the format for this. I thought it moved along at a nice clip, and I'm happy to continue doing it this way, but I'm interested in hearing from other folks as well. So thanks, everybody. Have a great IETF week, and enjoy the rest of your day.
Thank you, Aaron.